Do you feel the vibes?
All right, so you should all be on page what page is this? 11. Yes. Okay. You should all be on page 11. We're talking about properties of logarithms today. And so, because a logarithm is an exponent, right? They kind of follow the same properties as exponents, right? So we know, for example, if I have a to the power of 2 times a to the power of 3, that's a to the power of what? 5, right? So I add them, right? So you already are used to the fact that when you're multiplying powers, the exponents will add, and if you're dividing powers, then the exponents will subtract, right? We already know this connection between multiplying and adding exponents. So that brings us to the product property of logarithms. If you have log of m times n, you can split it up, give each element inside its own logarithm, and add them. Okay? So for example, if I have log base 2 of x times z, right? How many elements do I have inside the logarithm? 1, 2. When I split this up, each one of those gets its own logarithm. So it'll be log base 2 of x. And because they're being multiplied, it'll be plus log base 2 of y, right? I'm sorry, z. So I started with one logarithm, two things inside. I end with one logarithm plus another logarithm, okay? Two things separately, okay? And then if there is anything that I need to simplify, well, then I need to simplify them. So let's take a look at this one. I have log base 3 of 9y. How many things are inside the log? 2. So I'm going to separate them. This is going to be log 3 of 9 plus log 3 of y. We do not use the words distribute. We are not distributing a log. That is a different concept. What you do is you assign each element its own logarithm, and if they're being multiplied inside, you add them. Now you have to comb through and see if there are things that can be simplified. So for example, can the log base 3 of 9 be simplified? Yeah, what would that simplify to? A 2, right? Because the base is 3. What exponent of 3 gives you a 9? That would be a 2, right? Plus log base 3 of y. Yeah. Okay, so remember in the last two lessons, right? If you have log base 3 of 9, right? This is a base. So you're looking for the exponent of 3 that gives you a 9, and that would be a 2, right? Because 3 to the power of 2 equals 9. Okay, so here I have one element, another element. So this is going to be log base 2, 1 over 4, plus log base 2 of 5. So this one simplifies, right? 2 to the power of what gives you 1/4? Negative 2. So here's how you do it. 2 to the power of what gives you 4? 2. But to go from fraction to whole number, it's negative 2. Plus log base 2 of 5. This is, the one in red is what you guys took your test on or your quiz on last week, right? Okay, so that is from this lesson here. Okay? That is from this lesson here. All right? This is lesson 3. So take a look at what we did in lesson 3. How did we get 3 for this logarithm here? Right? The base is 2. What exponent of 2 gives you an 8? So when you come back here, I have a base of 2 right there. So I say 2 to the power of what gives you 1/4? Well, that's -2. Okay. Quotient property. Quotient property. If you have log m over n, if you're dividing these, then you separate and subtract, right? Just like when you're dividing powers, you subtract the exponents. So here, okay, so this is going to be log base 2 of 32 plus, minus log base 2 of a. Cool? So now I need to simplify this. Okay, so let's just start from the beginning. Take a look. I have a base of 2 here. So the question I need to ask is 2 to the power of what gives you 32? This is from section 3. This is from 7.3. And the exponent there is a 5. So this is just a 5. Minus log base 2 of a. All right? Okay. Here, log base 5 of n minus log base 5 of 125. So now, log base 5 of n, I can't do anything with that. But minus this, I have a base of 5. What exponent of 5 gives you 125? That's a 3. All right?
Does it matter if you put like the numbers from
Yeah.
behind the log?
Well, it has to be in the order. Yes. Okay. Okay. The final property is the power property. So look up here for a minute at what happens if you have a power. If you have log m to the power of p here, if there is an exponent, this exponent comes down and becomes a this comes down and becomes a coefficient. All right? So here it says use the properties of these logarithms to simplify each of the following. All right, so let's take a look here. I have log base 2 of root a. Well, first of all, in the world of logarithms, whenever you have a square root, remember you have to rewrite it as a to the power of 1/2, right? A square root always becomes an exponent of 1/2. Now, this comes down and becomes an exponent. So this becomes half log base 2 of a. Any questions up to this point? Yes. Yeah, I'm not there yet. Any questions up to here? Okay, now Marley's question. It says log base 2 of a equals 10. Now take a look at what we ended up with. We actually ended up with log base 2 of a. What does that highlighted part equal? 10. So you say this is half times 10. Sometimes half times 10. So this equals 5. Okay. Okay, thank you. Yes. Okay, so let's, either way. Okay, either way. Okay, let's take a look at this next one. The first thing I'm going to do is I'm going to bring this 3 and move it down. So this becomes 3 log base 2 of b. Now, it says here log base 2 of b is equal to 6. So this is equal to 6. So I write this as 3 times 6, 18. That's the answer. Now look. If you didn't have these highlighted parts given to you, then you just stop at half log base 2 of a, right? Then you would just stop at this stage, or you would just stop at this stage. Okay? Yeah.
And it'll never be give us the full answer.
Correct. Yeah. Yeah. Okay? All right. So now let's go ahead and solve some equations. Okay? All right. Let's take a look at this first one. I have a log and a log. The issue is I have this 1/3 in front. Now look, everything that we did here, you can actually work backwards. Like for example, this P moved down, right? But you could also just move it back up and make it a exponent, okay? So like over here, this 1/3 is down here, but you could always move it up and make it an exponent. So this becomes log base 5 of m equal to log base 5, 125 to the 1/3. Okay? So this is going with this property. If it moves down, it could also move back up, depending on what your needs are. So now, take a look at what I have here. Log base 5, log base 5. They're identical. When they're identical, what do I do with the insides? Set them equal to each other. So I have m equal to 125 to the power of 1/3. You can plug that in your calculator and get m equals 5. Okay?
So the logs cancel out.
Yeah. Yes, hang on. Okay. All right, I'm actually going to skip that one problem for now, and I'm going to go down to this page. Okay, there's all sorts of stuff happening in C here. First of all, there is a big problem, and the big problem is on the left side I have 1 log, which is fine. On the right side I have 2 logarithms, which is not okay. So I have to condense them, okay? So log base 7 of m. Now, what happens to these exponents? What can I do? What happens to these coefficients? What can I do? They go and become exponents. So this becomes log 7, 4 squared, plus log 7, 3 squared, 2 cubed. Okay, let's simplify that. Log 7m is equal to log 7, what's 4 squared? 16, plus log 7, 2 cubed is 8. Any questions on how we did that? Okay, now, I still have the problem of 2 logs on one side. So I need to somehow combine them. Well, let's see. Log 7 of m is equal to, okay, no, not yet. Okay, I have 2 logarithms here. Are the logarithms being added or subtracted? Added. And what did we learn here? Addition, right? Does it go with multiplication or division? Multiplication. So remember how my problem is that I can only have 1 logarithm here? I write down 1 logarithm, and these things, because it's addition, I'm going to multiply them. So 16 times 7. Oh, wait. Correct. Everything we did in the first part can also be like, you can it's like rewinding a video, right? It could also go backwards. Now, how many logs on one side, guys? How many logs on each side? 1. Can I now set them equal to each other? I can. I set this equal to that. Oh. How much? Oh, 128. Okay, raise your hands if you have questions. Now's the time. Questions? Yes. Yes, if you only have 1 on each side of the equal sign. That was the issue before. So, look here. Okay, I'm gonna do these in different order. Let's go to E first. We're being very rebellious today. Let's do E first. Okay. 1 log on the left, on the right side, 2 logs here. So first I have to condense those. Okay, so the 4 becomes an exponent. So I get log 2 x to the 4 minus log 2 of 5, log 2, 125. Okay, now I have a division, I have a subtraction here. That goes with division. So I say 1 logarithm, the first one divided by the second one. Why divided? Because there is a subtraction, equals log base 2, I forgot the 2 here, of 125. Now, 1 log, 1 log, what do? Set them equal to each other. So I get x to the 4 over 5 equals 125. Now what, guys? Multiply both sides by 5. And then, well, not square root, but, okay, how much is this? 625. I take, okay, so let's get the terminology right. What do I take the 4th root. So x is a cute little 5. Yeah.
So for the other, for like C, when there's a plus, you do multiply. And
Correct.
Subtraction.
Correct. Okay, let's take a look at this one. Again, 1 log on one side, 2 on the other. Not cool. We gotta condense. Okay, 2 becomes an exponent, and that's all I have. So log 7x squared equals log 727 plus log 781. Okay, log 7x squared equal to, I got a plus here. That means what do I have to do? Multiply. Log 7, 27 times 81. Okay, so I got log 7x squared. Log 7, how much is that atrociously big number? Okay. Oh, look, oh my God, that's so cool. It's the same numbers, but in different order. Isn't that cool? Right? 27 times 81. It's the same numbers, but in different order when you multiply them. I mean, because it's 2781, 2187. They're the same numbers, but come on. Okay, so now what do? Set them equal to each other and take a square root. Good. So x squared equals 2187. Take a square root. Take a square root. Okay, listen up though. Technically, x is plus or minus what? It's 9 times 3, 27. Is it 27? Yeah? When you take a... It should. Oh, shoot, it doesn't go in evenly. I'm sorry. What is it? How much is it? Okay, let's handle one thing at a time. Whenever you take a square root of both sides, it's got to be plus or minus, right? But if it's plus or minus, can both of them work in the original? Can you have log of a negative number? No.
So is it just?
Yeah. So it's just x is positive 46.77. Okay, raise your hands if you have questions. Go.
How do you know it's plus or minus? What kind of problem?
Anytime you have, we've been doing this forever, right? Yeah, any square root, both sides, it has to be plus or minus.
And then right or right. Okay.
Now remember, you can never have log of a negative number. So if you were to check these answers, that wouldn't work. Correct. Okay. Other questions? Other questions? Yes.
Technically, wait, 2 questions. Technically, did we cancel out the 2 log 7s when we set x squared?
We never cancel, but we don't use the term cancel. But when they're the same, you just set the insides equal to each other. Correct.
Okay, and then my other question is, in the first.
All right, so let's go up to D, right? Okay, so here I have 2 logs here. There should be parentheses. The parentheses must have, maybe if you printed it off, I don't know. When I converted to PDF, they must have gone away. So I have 2 logarithms here. A plus in the middle, it means I need to combine them and multiply. So I get log base 6 x plus 5 equals to 2. Okay, this is an odd one out from all the other problems. In what way? Equals 2. This does not have an equal to another logarithm. Remember, all of these other ones, we got to a point where you have log equal log, log equal log. This is a different one. You have a log equal to a number. Okay, when you have a log equal to a number, what is the answer to a logarithm always? An exponent. So you say, okay, this number 2 is an exponent. Every exponent needs a base. What's the base? 6. So x times x plus 5 is equal to 6 squared. Okay. Distribute. X squared plus 5x is equal to 36. Oh boy. Minus 36. And then you have to factor.
No.
Yes.
X squared plus 5x minus 36. And you figure out what goes in the book.
Yeah. Look at you guys, all experts now. Liam, what are you doing? Correct. But I didn't. So, come on. So, plus 9 minus 4. So, x equals 9. I'm sorry. And positive 4. Okay. Can you have x equals negative 9? No, you can't. Because you can't have that in here, right? So, that you throw away. So, your only answer is x equals 4. That's why I... Okay. Okay. Yes.
Can your answer never be negative?
No. When your answer goes in here, it shouldn't end up as a negative number. So for example, but since it's just x, correct. Correct. Like if this was, a different situation and you plug it in and you don't end up with a negative, it would have worked out. Yes.
How do you check the 4?
You check it like we did before, right? So like you plug it in here. Oops. So log base 6 of 4 plus log base 6 of 9. Does this equal to 2? Right? But what is this now? This is log base 6 of what? 4 times 9. Right, but when you put 4 into here, it's x plus 5, so it's a 9. And then you have to condense, right? Plus means multiplying. And then, well, because this is log base 6 of 36, which is equal to 2. Because the exponent of 6 that would give you a 36 is 2. What's log base 6 of 36? What exponent of 6 gives you a 36? 2. Yeah. Okay, now, no. whenever you get a negative answer, you have to plug it back into the equation. If you still end up with a negative inside the equation, then it's no solution. Okay. No, we did check, because if you put a negative number in here, you just end up with log of a negative number, which doesn't work. But suppose this was x squared. Now when you put a negative number in there, the square makes it positive, so it actually does work. Okay? All right. So the homework is a worksheet, right? And if you lose yours, you can always print it off of my Jag.
Press start.